Hey, this is Math Minutes Pro with Dr. Harrison. Today, we will talk about how to calculate the volume of a 3D figure. Now, we're looking at what is referred to as a composite 3D figure because there are two separate 3D figures that are connected. So let's begin by just building some vocabulary before we get into our calculations, all right? So here we have our cylinder. All right, and also what we have here is our prism. Very good. Now let's talk about some qualities of this three-dimensional figure. And I think I'd like to start by identifying some characteristics first of the cylinder. So we notice that we have our radius right here, and the radius is equal to 2 meters. So I'll just draw an arrow here pointing to that. That is our radius. Okay. Now, a key feature of the cylinder is that it has two bases, and the bases are the shape of a circle. All right. So we have our radius, that's 2 meters. Then we have our height of the cylinder. I'll just put an H equals 5 meters. Very good. Now let's look at the prism. What makes a prism, just like you have two bases in the cylinder, for the prism, we have two bases that are the same shape, just like in the cylinder. In the cylinder, the two bases that are the same shape are the circle. In this prism, two bases that are the same shape are the shape of a rectangle. So now you've learned that when you want to calculate, if you remember in elementary school, if you wanted to calculate the volume of a prism, you would just simply multiply the length times the width times the height. But I want to speak the language of calculating the volume with respect to middle and high school mathematics. So now we're still going to refer to the height of the prism, and we'll let that represent H. H equals 7 meters. Now let's look at the shape of the base of the prism. In this case, this is 3 meters. We're going to let that be our base, little b. And I think I'm going to make this one uppercase. There we go. I'll make that uppercase H. And then for the height of the base of the prism, we'll make that lowercase h. This will all make sense once we start getting into the formula. So when we're dealing with calculating the volume of a 3D figure, the general formula for that is volume equals big B times H. All right. Now this formula will work for calculating the volume of the prism and for calculating the volume of the cylinder. If you're calculating the volume of a sphere or something like that, you're going to use a slightly different formula. But we're going to focus on this general formula. Now, in this case, big B represents the area of the base. Now, this is very important because depending on what type of three-dimensional figure you're dealing with, the shape of the base can be a circle, or the shape of the base can be a rectangle. the shape of the base can be a triangle or a trapezoid. So in that case, when we're dealing with the area of the base, it may call for a different formula. So we're going to keep that in mind. So when you're dealing with a problem, solving a problem like this, what I recommend is that we begin by identifying a plan of action. All right? So our plan of action is right here. The volume, the total volume, and when I say total volume, I'm referring to the volume of the cylinder and the volume of the prism altogether. That is equal to the volume of the cylinder plus the volume of the prism. Very good. This is our plan. We're going to have our calculations on the left and right side, and then we'll come back and finish the problem. All right, so let's go ahead and get started. First, let's calculate the volume of the cylinder. So we're going to start with the general formula, V equals big B times H. Now, big B in this case, the area of the base, we want to calculate, use the formula for the area of a circle. All right, so what's the formula for the area of a circle? Pi times r squared, that's right. So we're going to put that in parentheses, pi times r squared times h. So notice we substituted the formula for the area of a circle for big B. Now, let's go ahead and start plugging in the numbers. So for pi, I'm going to use 3.14 times r squared. The radius is equal to 2. So I'm going to say times, there we go. Very good. And remember, that is squared times h. Now, let's go back and finish the problem. 3.14 times 2 squared, which is 4, so that's 3.14. And I think I'm going to, instead of writing h here, I want to write what the height is of that cylinder, which is 5. There we go. So 3.14 times 4, which is 2 squared, that's going to give us 12.56. 12.56. Very good. And that is times 5. 12.56 times 5 is going to give us 62.8. 62.8. Now don't forget to write the unit of measurement, which is meters cubed, because we're finding the volume of this cylinder, all right? Just like length times width times height is meters times meters times meters, which gives us meters cubed. So we've calculated the volume of the cylinder right here. Now what we need to find or calculate is the volume of the prism. So just like we wrote the general formula for the volume of a 3D figure, we're going to write it again over here. Volume equals big B times H. Now in this case, the shape of our base for the prism is a rectangle. So in this case, we want to find the area of the base of this prism, which is the shape of a rectangle. So we're going to write the formula, because the area of a rectangle, the formula is base times height. So we're going to write little b times h. And I think I want to make this capital H, because And I'm going to do it over here as well. That way you don't confuse it with little h for big B. That way it stays distinctive, okay? Now, let's see what we got here. And I want to make sure that I am consistent. So I represent the height of the prism as a capital H as well. So that's times big H for the height of the prism. Now let's go ahead and substitute. So according to this figure, the base is 3. So that's 3 times the height is 6 times the height of the prism, which is capital H, which is 7. That's why I went back and did that, all right? So we can distinguish capital H from lowercase h, all right? Now, we got 3 times 6, which gives us 18 times 7. Bring that 7 down. 18 times 7 is 126. 126. And that's meters cubed again. All right. Now, I'm going to go ahead and separate these calculations. All right. Because what we're dealing with is we have part number 1, which is right here. This is number 1, where we calculated the volume of the cylinder. Then we went to part number 2, where we calculated the volume of the prism. Now I'll just put prism down here. That was step number 2. And now we're over here at step number 3. Very good. So, to get the total volume, all we have to do is add up these two values. The volume of the cylinder, which is 62.8, plus the volume of the prism, which is 126. Therefore, our total volume, okay, is going to be equal to 188.8 meters cubed. This is our final answer. This is a 3-step problem. First, we had to calculate the volume of the cylinder, calculate the volume of the prism, add those two together to get the total volume of this composite figure. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page in my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.